Welcome back to 17.2, Explain 2. We'll be going over evaluating basic trigonometric functions using a calculator. In addition to that, I did pull this from your textbook just as a little FYI. So let's say if a radius r and angle theta are given. So we talked about circles, right? I know it's not perfect, but that's my circle, so don't judge. Let's say I have a radius, goes from center to the edge, and I'm given an angle measure, which I don't know. Just so you know that the x and y coordinates can be found for that particular angle. So if I don't know what x and y are, I can figure that out by multiplying radius times cosine theta, comma, for the x value. And for y value, I can do radius times the sine of theta. Let's say, on the other hand, they give me a point if x and y is a point on the circle, and they give me an r value. I can figure out what theta is, or the sine and cosine of theta, or tangent of theta, by just writing for sine, that would be y over radius, cosine would be x over radius, and then tangent would be y over x. So those values can be found, just so you know. And that's going to be really useful for our first word problem, your favorite. So it's about a Ferris wheel, because there's a picture of a Ferris wheel. Let's say a Ferris wheel with a diameter of 45 meters and 24 seats is spread evenly around the outside of a wheel and is stopped at a position, because if you've ever been on a wheel, one of those Ferris wheels, they do stop to load and unload people before they do the whole ride. Using the center of the Ferris wheel as the origin, so let's say center of our Ferris wheel is 0, 0. Probably should have chosen a different color than that, but it's there, 0, 0. What is the horizontal and vertical position of seat 8? Which I guess is that one right there. So that's the first question. How far above the bottom of the wheel is seat 8? Okay, so from the bottom to where seat 8 is, how far is that? And solve the problem using radians. Okay. First things first, let's do the easy stuff. Let's just figure out what the diameter is. Well, the diameter is about that much, which is 45 meters. Now remember, radius is going to be half my diameter. So half of 45. Take some time right now. What is half of 45? What would that be? About 22.5 meters. Okay, let's go on to the next part. Too bad, hopefully. Hopefully, I say. So let's see. Well, remember, they want this in radians. So remember, a full revolution around a circle could either be 360 degrees or 2 pi, but they want this in radians, so we're going to use 2 pi, which is that. And how many seats are there? I think they said there were about 24 seats there. So let's work that out. What would that be? So if we reduced that, that would be about 1 pi over 12, or pi over 12. How many seats are there from seat 8 to seat 1? Well, we could count, but you know, I don't want to count if we can use math to make this a little faster. So let's say there's 8 seats, take away 1 seat, which is the first seat. What would that be? 7, right? There's about 7. So there's a number of seats of 7 seats. The angle measure is about pi over 12. So let's figure out what that would be. I think that would be 7 pi over 12, which is not bad. Okay. So let's figure out what the x and y coordinates of the 8th seat are. So at least we could answer our first question, and then we can try to answer our second question. So radius was about, oh, I kind of forgot. What is the radius? Radius was about 22.5. 22.5, might as well, right? Cosine of 7 pi 12ths and sine of 7 pi 12ths. We're going to use our Desmos calculator again off screen. I'm going to show you how to do that to figure out our x and y, what our coordinate is for the 8th seat, and then we're going to try and fill in some of these sentence starters to finish out part A. Alright, again I'm going to use my Desmos calculator. Make sure it's in radians, just so you know. We're going to multiply 22.5 times the cosine of fraction 7 pi over 12. And that's about that many, that's about negative 5.8. And last but not least, we're going to do our radius again, 22.5 times sine of fraction 7 pi over 12. And that's about 21.7. So keep those values in mind. We're going to go ahead and write this on our paper. Alright, so that's about negative 5.8 and 21.7. So let's look at the sentence starter. It says that the 8th seat is, well, left or right is going to be our x value. So it's about 5.8. Now because it's negative, is it going to be left or right? And you can actually see from the picture, it's on the left side. And here it's going to be about 21.7 meters for our y value, above or below the center of the wheel. Well, even though that's positive and that's negative, we can kind of see that yes, the 8th seat is actually above the center. Okay, so we answered the first question. Now it says the center is how many feet above the wheel? Well, center's right in the middle. We said our radius was about 22.5, so it's got to be about 22.5 above the ground. And since this is stopped about 21.7, what we could do is we could add 22.5, which is from here to here, to that 21.7, if I could draw it. And let's figure out about how many in total that is above the ground, which should be about 44.2 meters above the ground if you added those together. Alright, let's go on to part B. So it says an airplane begins to descend toward a runway. So here's my runway, here's my plane. Don't judge my picture, but it's going down, it's descending 1 mile away at an angle of descent, oh, sorry about that, of negative 5 degrees, okay, to the horizontal. Okay, what is the change in elevation after it flies 5,000 feet horizontally towards the runway? Alright, again, we're going to be using our calculator, so please make sure, like it says here, that we switch it to, well, here they're giving us our value in degrees or in radians. I don't know about you, but that symbol looks like a degree to me. And it also says to make sure you select the degree symbol. So just keep that in mind. Alright, so using the beginning of the descent as the origin, the horizontal distance traveled by the plane should be created as a, so if we created this, our vertical, right, to our horizontal. So our horizontal being x and y, that would be our x coordinate and our y coordinate. Since those are the case, we're using our x and y coordinate. Remember, there was only, just going to flash back to this, you thought it was useless, but it's not. Since they're using x and y, we'll use sine, cosine, or tangent if they're using x and y. Tangent, right? And you can see here, they want us to fill that in with tangent. Now, what was our degree measure? Negative 5 degrees, right? Our y value we don't know, but we do know our horizontal, which is our x value of 5,000. And they even say, what is the change in elevation? Elevation is our y value. Horizontal movement is our x value. So just keep that in mind. Actually, write that in your notes right now. Elevation is going to be my y value, whereas my horizontal change would be in my x value. Alright, so what we're going to do is we're going to figure out what this would be cross multiplied. If you're wondering, how did they get to this? So if I wrote tan negative 5 degrees over 1 equals, sorry about that, equals y over 5,000. I would cross multiply, and that would be 1y equals 5,000 times tan negative 5 degrees, which is essentially what they got here. They just kind of wrote it backwards. So let's go ahead and compute this in our graphing calculator, or I should say our Desmos scientific calculator. I'm going to split the screen right now to show you how to do that. So remember that our whole problem was in degrees, so even though this says radian, I'm going to switch it back to degrees. And I'm going to type in 5,000 times tan negative 5 degrees. And that would be about, let me also make sure if I could put the degree function on here. If not, that's fine. But that would be about negative 437 feet. Now, there is no such thing as negative, but that's telling us the degree, like the direction, right? Which the plane's going down, so of course it's going in a negative direction because it's going down. But the elevation drops about 437.4 feet. So let's write this on our paper right now. So that would be y is equal to negative 437.4, and that means the elevation drops. That's why that negative symbol is there, about 437 feet. 0.4. Just like it says here, stop and do your word problem. That's in your packet, and we'll come back to discuss your homework in just a few minutes.